When we discuss rational functions, there are many different types of asymptotes. The easiest asymptotes are the vertical asymptotes. Okay? It says in bold, asymptotes are written as equations. So you must have x equals a vertical asymptote and y equals a horizontal asymptote. That's very important, and I'm going to look for it on your quiz. Okay? To find a vertical asymptote, you take the bottom and you set it equal to 0 and solve. So here I would take the bottom, x plus 2, set it equal to 0, and the vertical asymptote for this would be x equals negative 2. On a graph, what you would do is go over here and put a dotted line. It's vertical, up and down, where x is negative 2.
You have to write down a number?
Yes.
For the answers?
Yes. I mean, I'll show you how to do a whole homework problem, but I'm trying to do the different pieces before I put it all together. Okay? So, there are also horizontal asymptotes. When you have horizontal asymptotes, there are 3 rules. In this case, n is the degree on the top. M is the degree on the bottom. Okay? So if n is less than m, so if the degree on the top is less than the degree on the bottom, the horizontal asymptote is y equals 0, which is the x-axis. Okay? The second rule says, if the degree of the top equals the degree of the bottom, then the horizontal asymptote is the leading coefficient of the top over the leading coefficient of the bottom. So here the degrees are both 1. So what I would do is I take y equals the leading coefficient on the top, which is 1, over the leading coefficient on the bottom, which is 2. So therefore, my horizontal asymptote would be at y equals 1/2. If this is 1, that would be right about here. And I draw my line. For the third rule,
Bye, Princess. Enjoy your trip.
if the degree on the top is greater than the degree on the bottom, this is called a slant asymptote. Okay? It's called a slant asymptote because it's going to look like something like y equals x plus 5 or y equals x squared plus 5. What you do is, so if the leading coefficient is greater on the top than on the bottom, you do division. And then whatever your answer is, not including the remainder, is the horizontal asymptote. These are also called end behavior asymptotes because it tells you put your head down, please.
Put your head down.
I'm waiting for you to continue. Put your head down.
Put down. Put your head down. What are you thinking for?
Thank you. So, I'm going to repeat this.
Come on, man.
If the degree on the top is greater than the degree on the bottom, it's called a slant asymptote. It is called slant asymptote because it is a slant. So, you will get an answer that's like a line or a parabola. It's called an end behavior asymptote. Let's say it was a line. That means your function is going to approach that line.
But it will never cross it.
For horizontal asymptotes, it can cross it. For vertical asymptotes, it can never cross it. But generally speaking, you can assume that it probably won't cross it. But it could, but not all the time. So what you do is you do division from the top and the bottom, and you take everything, not including the remainder. So on the back, there's an example. The degree of the top is 2, the degree of the bottom is 1. You can use synthetic division because the denominator is just x plus something or x minus something. So it's x plus 1, so I solve, so x plus 1 equals negative, or x plus 1 equals 0. X equals negative 1, so I do synthetic division with this. which is done here. Bring down the 1, negative 1, negative 1. This is the remainder, so I don't care about the remainder. So that's x minus 1. This is my slant asymptote. So when if you were to graph that, you'd have some vertical asymptote, which we can see x plus 1 equals 0. So that would be x equals negative 1. So our vertical asymptote would be at negative 1, so that'd be here. And our horizontal asymptote, I'd graph this line. So that'd be here and then up 1 over 1. So our horizontal asymptote would be a dotted, or slant asymptote would be a dotted line going like this.